Welcome to lesson 7.6, solving systems of linear inequalities. So we've already looked at systems of linear equations. Now we're looking at systems of linear inequalities. And remember, inequalities mean that we will have an inequality symbol. So it would be something like y is greater than, y is less than or equal to, greater than, or greater than or equal to. So our inequalities, again, just anything that doesn't have that equal sign, it would have the less than, greater than, or our two here, less than or equal to, greater than or equal to. Then just a couple general reminders right here at the top of our notes. From the last time that we graphed inequalities, you want to keep in mind that if we have just less than or greater than, you'll end up using a dashed line. If it's less than or equal to or greater than or equal to, you use a solid line. And before we do any graphing, you want to make sure your equations are in slope-intercept form, which is typically y equals mx plus b. M is always the slope, b is always the y-intercept. But again, for inequalities, it's the same equation type setup, but instead of the equals, we would have our inequality symbol. So the first thing on all problems that you want to do is make sure we're in slope-intercept form. Then, if you did forget on how to graph our inequalities, I'll also attach an additional video from those first lessons when we went over graphing inequalities to help you as a refresher. But with today's lesson, you'll notice that we have only roughly 7 examples. And with the graphing, that's the main method for all inequalities. So when we're looking at the system of inequalities, our main method that we're looking at in this lesson is the graphing. When we get down to the word problem, we would just be setting it up, but we're not doing the actual solution. So let's look at example 1, A and B here. Graph the system of inequalities. Now, you'll notice with these, I did not write a single answer because my answer ends up being a whole region. Where you see the shading on my graph, the answer to this system of inequalities would be anywhere in this region. So there's multiple answers to each one of these because there is a whole region that is correct. So if you shade the wrong region, you would end up with the wrong answers. So the shading part is going to be very important. So with A, let's do the top equation first, which is my green line down below. I know it's less than or equal to, so it's a solid line, and it's already in slope-intercept form. So 2x plus 3 tells me I'm going to start at the positive 3 here for my y-intercept, and my slope is a positive 2x, meaning I'd go up 2, right 1. And then connect the dots and draw in our solid line. Then for our other equation, y is greater than negative 1/4 x minus 1. So in this case, I know it's a dashed line, and my y-intercept's a negative 1. So my first point, over 0, down 1. From that point, I follow my slope, down 1, right 4. And there's our next point, and then we can draw in our dashed line. So at this point, you should just have your 2 lines. Now we need to figure out which way the shading goes. So again, if your lines do not pass through the point 0, 0, I use that to check for my shading. So in this case, checking 0, 0 in the top equation, it ends up being 0 is less than or equal to 0 plus 3. So is 0 less than or equal to 3? Yes, it is. So on that one, I'll be shading toward the 0, 0, which would be to the right of my line. Then For the pink line, we're going to check 0, 0 again. So y is greater than negative 1/4 times 0 minus 1. So is 0 greater than 0 minus 1? Yes, 0 is greater than a negative 1. So again, we would be shading toward 0, 0. So that would be above the pink line. So we're shading right of the green line and above the pink line, which would be this region right here. So any ordered pair in that region would be a solution to these two equations as a system. So let's look at B. In B, neither one of our equations are in slope-intercept form, so I rearranged them into slope-intercept form. On top, I just need to add x to each side to get rid of the negative x. So that top equation is y is greater than or equal to x minus 2. In the bottom equation, we had to subtract the 2x from each side, then divide everything by a negative 2. So remember, if we're dividing ever by a negative, the inequality sign flips. So this one would become y is less than x plus 1. So in this case, graphing our top line here, y is greater than or equal to x minus 2. I know it's a solid line. Starting at a negative 2, our slope is 1x, so up 1, right 1, up 1, right 1. Draw in your solid line. Don't worry about shading yet. Then with the next one, y is less than x plus 1, it's a dashed line crossing the y-axis at a positive 1. Slope is still up 1, right 1, up 1, right 1. So in this case, we end up with two parallel lines. Now the question is, are we shading in between them, outside? Where are we shading? So with the top equation, check in 0, 0 to find out for my shading. So put a 0 in for x and y, we end up with 0 is greater than or equal to negative 2. That is true, so we would shade above this line toward the 0, 0. With our bottom equation, putting in 0, 0, is 0 less than 0 plus 1? So 0 is less than 1. Yes, that's true. So we would shade below the golden line here. So our region is shaded in between these two lines. So then C and D. In C, we have to rearrange into slope-intercept form. So the top equations subtract x, and we end up with y is greater than a negative x plus 4. On bottom, we're adding 3x to get rid of this negative 3x, so y is less than 3x plus 1. Both lines are dashed lines, so we'll start with the top equation's graph, crossing the y-axis at a positive 4, so starting over 0, up 4. Our slope is a negative 1x, so it's down 1, right 1. Down 1, right 1. Connect them by drawing in your dashed line. Then we have 3x plus 1, so we're starting at a positive 1. Our slope is up 3, right 1. Up 3, right 1. Connect those points with our other dashed line. Now we need to figure out the shading. Neither one of my lines goes through the point 0, 0, so I'm going to check 0, 0 with both. So in this case, on the top equation, is 0 greater than 0 plus 4? 0 is not greater than 4, so we would be shading away from 0, 0, which would be above this blue line. Then with the bottom equation, checking 0, 0 again, ends up with 0 is less than 1, which yes, 0 is less than 1. So for the orange line, we'd be shading to the right. So above the blue, right of the orange gives us this region right up here. So any numbers in this region would be a solution. And our last example to start, D. So top equation already in slope-intercept form. So starting at 0, 1 over 0 up 1 is our first point. Slope is 2, so up 2, right 1, up 2, right 1. And again, it's a dashed line, so we would draw in our dashed pink line. Now for the bottom equation, to solve for y, we divide both sides by 2. So y is greater than or equal to 1/2 x. And it would technically be a plus 0 here. Nothing's there. So that tells me my y-intercept is at 0, 0. My slope is 1/2, so up 1, right 2. Up 1, right 2, drawing our solid line. Now we need to check for shading. The top equation does not go through 0, 0, so I can check 0, 0 with that one. Ends up with 0 is less than 1, which is a yes, that's true. So in this case, we would be shading toward 0, 0 from the pink line, which would be to the right of it. Now for the bottom equation, if we tried to check 0, 0, it's going to come out as a yes because that line goes through 0, 0. So we don't want to check 0, 0. Instead, we want to pick another point that's not on that graph to check. So I'm simply going to check 1, 1. So in this case, plugging in a 1 for x and a 1 for y, we have 1 is greater than or equal to 1/2 of 1. 1/2 of 1 should be a 1/2 here, not a 1, but is 1 greater than 1/2? Yes, it is. So in that case, we'd be shading toward the 1, 1, which would be above the green line. So we're to the right of the pink, above the green, which is this region right up here. So now in example 2, they give us the graphs. They want us to write the inequalities. So we're writing the system. So what I look at with the graphs is I first just write them as equations. I find the line, and I look at what info I know. This graph's y-intercept is -2. So I know my equation is going to end in a -2. B is a -2. Then I need to figure out the slope of this line. It's up 1, right 1. Up 1, right 1. So my slope is just 1x. So that equation would be y equals x minus 2. Now to make it into an inequality, we would first need to decide, is it solid or dashed? Well, it's dashed, so I know it's less than or greater than. Then the shading's off to the left. So in this case, what I would want to think about is, well, if I'm looking what numbers are off to the left of this line, it would be all the values greater than. And the way that we know that is if I'd pick a point here, let's say I used a point in the shaded region, 0, 2. So if I'm putting in 0, 2, the 0 goes in for x, the 2 for y. So that'd be 2 is greater than 0 minus 2. 2 is greater than a -2, so we know our symbol would be greater than because they shaded that way. With the bottom one, again, I'm taking the info from the graph. It crosses our y-intercept at 0, -4, and my slope would be up 1, right 2. Up 1, right 2. So actually my slope here is not 2x, it's 1/2 x minus 4. So 1/2 x minus 4. Up 1, right 2 would be a slope of 1/2, up 1, right 2. So in this case, now we need to figure out the shading. It's a solid line, so we know it's an or equal to. And if I think about the point 0, 0, which they shaded toward, if I'm thinking 0, putting in 0, 0 to this top equation, let's say, is 0 greater than 2 times 0 minus 4, or is it less than that? Well, in this case, if I put a 0 in for both, I'd have a 0 and a -4. They shaded toward the 0, so 0 is greater than -4, so it would be a greater than or equal to symbol. So our final equation should be y is greater than x minus 2, and y is greater than or equal to 1/2 x minus 4. If we look at the other equation here, First off, we'll start with the vertical line here. Vertical line at x equals 4. Any vertical line is just x equals the number that it goes through vertically for the x value. So then it's a solid line, and our shading was to the left of it. Anything left of this vertical line would be less than, and because it's solid, it's less than or equal to, so x is less than or equal to 4. Now for the pink line here. We're crossing the y-axis at a positive 4, so our b of our y equals mx plus b is a positive 4. Figuring out our slope, down 1, right 1, down 1, right 1, so our slope is a negative 1x or negative x. So the equation of that line is y equals negative x plus 4. Now for the shading, it's shaded down to the left of that line. So in this case, if it's down to the left, I know it's less than, just from looking at it. Or again, I could try a point like 0, 0. I put a 0 in for y and x, and I'd end up with 0 is something to 4. So is 0 less than or greater than 4? Well, it's less than. So if we're shading toward the 0, 0, our answer would have to be a less than. Because it's a solid line, it's less than or equal to. So our final answer here would be x is less than or equal to 4. Y is less than or equal to negative x plus 4. Then our last example for these practice problems, or for these notes I should say, is a word scenario. It says, suppose you can work a total of no more than 20 hours per week at my 2 jobs, or at your 2 jobs. So our maximum amount of hours per week is 20 hours. So I know my 2 jobs added together are less than or equal to 20. So if I make one job X and one job Y, X plus Y is less than or equal to 20. That's our first inequality. Then it says babysitting pays $5 per hour. Cashier job pays $6 per hour. We need to earn at least $90 per week to cover expenses. Write the system of inequalities. So if babysitting was X, cashier was Y. X plus Y is less than or equal to the 20 hours that we can work total. Then $5 per hour for babysitting, $6 per hour for cashier. So 5x plus 6y is at least $90 per week. So at least would be greater than or equal to 90. So then we'd have our 2 equations here for, or our 2 inequalities for our system of inequalities. So if you forgot how to do the basics of the graphing, I know I skimmed over it in this lesson because we've been doing graphing for a while, but I will attach additional videos on how to go through this process if you need a refresher from previous lessons.